Welcome. In Chapter 10, we'll learn how to set up spreadsheet models. First, though, let's take a review for the midterm exam. People did really well on the exam, and we'll just go ahead and go into it. So the first question was about students taking the graduate management admissions test, and they were asked about their undergraduate major and their intent to pursue their MBA as a full or part-time student. And we are given a joint probability table with the results of that particular survey. And we'll take a look at the answer. So here we see the joint probability table. And again, we have joint probabilities in the center square, and these are going to be the probabilities that are ands, full-time and business student, full-time and engineering, and so on, part-time and business. So the first, and of course the margins are the probability of being full-time on the rows, being part-time on the rows, being business on column, engineering on column, and other on column. So those are our marginal probabilities, and the joint probabilities, again, are the ones in the middle. So question A is, if the student intends to attend classes full-time in pursuit of an MBA, what is the probability that the student was an undergraduate engineering major? So here we have a conditional probability. The probability you were an undergraduate engineering major, given that you're going to pursue an MBA full-time. That's equal to the probability, the joint probability of being engineering and full-time, which is 0.1510, divided by the probability of being full-time, which is the marginal probability, 0.6130. And that's equal to 0.2463, or many people rounded that off to 25%. So again, this is a case of a conditional probability is equal to the joint probability divided by the marginal probability. Question B, part B of question 1, is if a student was an undergraduate business major, what is the probability that the student intends to attend classes full-time in pursuit of an MBA? Well, again, this is a conditional probability. What's the probability they'll attend classes full-time given that they are a business undergraduate major? Well, that's going to be the joint probability that they were full-time in business, which is 0.2697, as we see in the joint probability table, divided by the probability they're a business student, which is 0.3847. And that gives us about 70%, 0.7012. Okay, question 2 lists 3 techniques used in descriptive analytics. These could be things like data queries, reports, statistics, visualization, what-if models. Question 3 was a true-false. Data visualization is used for detailed analytic procedures on your data. And that is false. It's used for summary and to see high-level patterns. It's not used for detailed analytic procedures. Question 4, true-false again. Graphs are used when the reader needs to make precise comparisons between different values and not just relative comparisons. That also is false. Tables are used for making precise comparisons, and that's one of the types of data visualization that's out there. And Graphs are, again, not used. They're for detailed analytical comparisons or precise comparisons. They're for summary and high level. Question 5 is, what is a line that provides an approximation of the relationship between the variables? And that's called a trend line. Question 6 was another true-false. You should include axis titles in your sparkline charts. And that, of course, is false. Sparkline charts do not have axes. Define probability. I was looking for you to include concepts like it's a numeric measure of likelihood that an event occurs. And everybody got that one right. What is the probability that has the highest uncertainty? Well, 0 means we're certain it won't occur. 1 is we're certain it, 0 is we're certain it will not occur. 1 is we're certain it will occur. So 0.5 is going to be our highest uncertainty. We're equally unsure if it's going to occur or not occur. Question 9 is a true-false. The Poisson distribution deals with the time between occurrences of successive events as time flows by continuously. And that's false. That was an exponential that deals with the time between occurrences of successive events. A Poisson distribution deals with the number of events that happen in a given time period. So a Poisson is a discrete and not a continuous distribution. And then finally, question 10, multicollinearity refers to the correlation among independent variables in multiple regression analysis. And of course, that is true. Okay, any questions on that? Okay, let's go on. Let's also look at the graded homework. It's due before class. And it was problem 810, dealing with United Dairies. And so I'll open up that worksheet and we'll go through it. And there we go. So we have a worksheet on sales by week for United Dairies. So part A, I'm just going to highlight the sales column, and I'm going to do an insert and then a line graph. And we have our sales trend. It's a horizontal with a slight upward trend. Now, next part is we want to do exponential smoothing with a smoothing constant of 0.4. So I'll go over to data analysis. And exponential smoothing. And my input range is my sales. My damping factor is going to be 1 minus the smoothing constant. The smoothing constant was 0.4, so my damping factor is 0.6. And I'm going to put my output range, let's just put it in D2, starting in D2. And so now I've got my, my estimates based on exponential smoothing. Now, we also have to calculate the mean square error. So to do the mean square error, I'm going to calculate the forecast error, which is going to be equal to our actual value minus the y hat, or the estimated value. So I'm going to start in row 3, and I'm going to say B3 minus D3. And that's going to give me my forecast error, the actual minus the prediction. And I'll drag these down. And I'll scrunch this, move this over a little bit. Sales chart, okay. So this is my actual forecast error. Let's now square that. So I'll just take equals E3 hat 2 to square it. Bring it down. Then I want, for the mean square error, is the average of this squares I get. So I can sum them and divide by count, or I can just use the average function. So I'll do that. And I get 44,453 and some change. And then finally, we want to use our exponential smoothing with a smoothing constant of 0.4 to make our estimate. Well, I'm just going to come over to my last value for week 12 actual and drag it down, and that'll give me my estimate for week 13. That's the forecast for week 13, 3,117 units. Okay, any questions on that? All right, let's go on. I'll go back to sharing the spreadsheet. So let's talk about models in spreadsheets. And this is where we take mathematical and business problems and we put them into a spreadsheet. And then we can do what if type analysis on them. So let's first look at the elements we have to do, or the guidelines we have for building a good spreadsheet model. And we're going to develop influence diagrams to help us. Then once we have that, we can define our parameters, our decision variables, and our formulas for our model. And these will all be based on a business field like accounting or finance or transportation. And then we'll put that model that we've defined abstractly into a spreadsheet. So Newland Plastics is the example we'll be using for the first part of preparing models. And it produces a line of cell phone covers. And its best selling is its Viper model, which is a very thin but durable cover. The annual fixed cost for producing the Viper cover is $234,000. The fixed cost includes things like management time, advertising, and other costs that are incurred regardless of the number of units that are eventually produced and sold. In addition, the total variable cost, including labor and materials, is about $2 for each unit produced. Nolan is considering outsourcing the production of some of products next year, including the Viper. It has a bid from an outside firm to produce the Viper for $3.50 per unit. Obviously, this is more expensive than the variable cost of $2 for Newland. But Newland also has to consider its fixed costs. The exact demand for the Viper for next year is not known. And so Viper would like to compare the cost of manufacturing versus outsourcing across various production quantities. This is known as a make or buy decision. So an influence diagram is a visual representation that shows the entities that are involved in a particular model. So the parts of the model are designated by circles or ovals, and then arrows show which part influences which other part. So here's a first pass. This figure shows an influence diagram for Nolan's total cost of production for the Viper. Total manufacturing cost depends on fixed cost and variable cost. And variable cost in turn depends on the variable cost per unit and the quantity required. And we see this all represented in our influence diagram. Okay, this shows an expanded influence diagram that includes the outsourcing option. So this is kind of a modular approach. First, we build our total manufacturing cost, and then we can build our total outsource cost, and then we can put that all under the difference of cost between the two. So let's take a look at this. Obviously, the total outsourcing cost is going to be equal to the purchase cost per unit times the quantity required. So quantity required goes into both formulas, total outsourcing cost and total manufacturing cost. And it's a decision variable because as this varies, so does the cost savings between manufacturing and outsourcing. So in building a mathematical model, we're going to consider, in this case, the cost of manufacturing, and that will be determined by the fixed cost of manufacturing, the variable cost, and these are input parameters, the quantity required, which is a decision variable, and then a formula, total manufacturing cost, which is equal to the cost to manufacture Q units. Well, the total manufacturing cost is for Q units is going to equal the fixed cost plus the variable cost times Q. And with Viper, we have a fixed cost of $234,000 and a variable cost of $2. So the total manufacturing cost for producing Q units is equal to 234,000 plus 2 times Q. The mathematical model for purchasing Q units is going to be equal to the price per unit, P, times Q, the quantity. And since P equals 350, the total cost of purchasing Q units is going to equal 3.5 times Q. Now, to continue on with our model, we're interested in the savings or the difference between manufacturing cost and purchasing cost. Well, the savings for Q units that we produced is going to equal to the manufacturing cost for Q units minus the purchasing cost for Q units. And then Newland has to decide for what quantities is it more cost effective to outsource rather than produce, and vice versa. So that's going to look at what quantities where do we have a savings from outsourcing greater than 0. So we've got our elements for Newland Plastics. We have our components, Q, quantity, fixed cost, variable cost, total manufacturing cost, purchase per unit, total production cost, and savings cost for Q units. So TMC, TPC, and S are functions. Q, fixed cost, variable cost, and purchase cost are not functions. So we're going to represent the functions with formulas in Excel. And the values Q, FC, VC, and P will be entries in our spreadsheet. So the quantity Q is known as a decision variable. So the number of Vipers to make or buy for next year is really a decision. And so we want to see if we vary that, what our savings will be depending on if we manufacture or purchase. Fixed cost, variable cost, and purchase per unit cost are parameters. They're fixed and we just enter them as constants in our model. So let's take a look at Newland and go through the process for that model. Okay, so here's our spreadsheet with that model. So again, we've got a couple of sections. We've got parameters, and we said our fixed cost, 234,000, was a parameter. Manufacturing variable cost is a parameter, and outsourcing cost per unit is a parameter. So we just enter those in as constants. Then we have our model, and quantity is a decision variable. And then we have the total cost to produce as a formula. So that's going to be equal to our fixed cost plus our quantity times our variable cost. So at a quantity of 10,000, we get $254,000 is the total cost to produce. Then total cost to outsource is going to be equal to, it's a formula again, and it's going to be equal to the cost per unit for outsourcing, B7, or $3.50, times Q, quantity, which is in B11. So that's 35,000. Savings due to outsourcing is equal to 254,000 minus 35,000, or B13 minus B15. And we get that as our savings. Now, the question is, how does our savings due to outsourcing change as we change values? Well, we could manually change 10,000 to get other values. So for example, you know, I can come in here and I can go 20,000. And then we can see how much we would be saving there. It's different. And I go back to 10,000 and so on. So we could do that manually, but Excel has a great tool called Data Table that'll help help us in this type of analysis. So what we'll do is, first thing we do is we get a quantity and we want to vary that. And the problem in the book called for increments of 25,000. So I just entered in 25, 50, 75, and so on, 125. So I have the various quantities that we're interested in. Then up here, I put in B17 equals B17, which is our formula that we want savings due to outsourcing. And then what I'm going to do is highlight the quantity and that formula. I'm going to then get a data table what if analysis, and I'm going to say the quantity that I've entered in here, this column, which is in a column, the quantity is in a column, is going to be substituted into cell B11, which is my quantity for my model. So let's go ahead and do that. So I'm going to select this. So I select quantity and my formula for savings. I go over to data, what if analysis, and I'm going to choose data table. I don't have a row input, I have a column input. In other words, my quantity was entered into a column. So I'm going to then say that should be substituted in iteratively into cell B11. And then we can see our actual quantities for savings due to outsourcing. So at 150,000 units, it's still cost effective for Newland to outsource. At 175,000, it's losing money outsourcing. It's more effective to manufacture it in-house. So we can see that Excel did a lot of the heavy lifting for us. Okay, so let's go back here. Okay, so again, here's a representation. We'll just take a quick overview or review of it. Column A is where we put our labels. Name of the company, name of the problem, parameters, model, and then the various variables that are parameters, the various functions and formulas and decision variables that are in our model. So input parameters, FC, VC, and P are placed in cells B4, 5, and 7. We offset P from them because it's for outsourcing. The first entry in the model is the quantity, which is the number of units Viper will produce or purchase. And it's shaded to signify that it's a decision variable. The formulas corresponding to total manufacturing cost, total purchase cost, and savings are in B13, B15, and B17. And we just start with a placeholder of 10,000 units. And at that point, we can see how much savings we get. So again, we could have gone through a trial and error approach to solving the problem, but instead we opted to use the tool, the what if analysis data table tool. So some of the principles of building good spreadsheet models: separate the parameters from the model, document the model and use proper formatting and color, and use simple formulas. So let's take a look again at what we did with that data table. There's a couple of tools we can use: data tables, goal seek, and scenario manager. So in this part of the lecture, we're looking at data tables, and we looked at a one-way data table. Next, we'll look at a two-way data table. So If we consider how savings due to outsourcing changes as the quantity of Vipers required changes, this should help us answer the question for which values of Q, the quantity, is outsourcing more effective. A one-way data table changing the value of quantity and reporting savings due to outsourcing would be very useful. So again, we set up a model in our spreadsheet and we did that work. So the first step in creating a one-way data table is to construct a sorted list of the values you would like to consider for input. So that was our quantity. We had it from smallest to largest in 25,000 unit increments. And we see in this one that we put it in, they put it in columns D5 through D17. And we had the column label up in D4. So the column of data is the set of values that Excel will use as inputs for Q. Since the output of interest is savings due to outsourcing, we have entered the formula for savings equals B17 in their case, E4. And then we selected the quantity and our formula, that whole block. We went to what if analysis, data tools, data table, and then we put in B11 because our input quantities are in the column, and we clicked OK. And we got this result. So Excel gives us the table populated with the value of savings due to outsourcing for each value of quantity in Viper's table. So when Q equals 25,000, we see that the savings are equal to 196,000. When Q equals 250,000, the savings are equal to a minus 141,000. So a negative value for savings due to outsourcing means that manufacturing is cheaper than outsourcing. So not only have we quantified the savings due to outsourcing for a number of quantities, we know too that for quantities of 150,000 or less, outsourcing is cheaper, and that for quantities of 175,000 units or more, manufacturing is cheaper. At 150,000 units, the savings due to outsourcing is only 9,000. So we've provided management with valuable information that they can use to make a decision on building in-house or outsourcing. Next, let's consider a two-way table. So in this scenario, we've got the case where we're not only have one company bidding on the outsourcing, but we have 5. And so we're going to have a two-way table. We want to see how things change based on the bid price from our pool of outsourcing vendors, as well as the quantity. So let's take a look at how we do that. So I'll go over to our spreadsheet. So now we've got our model. Again, it's the same model, but we're going to use a two-way data table instead of a one-way. So in place of quantity, I put the formula for what we want to check out, in this case, savings due to outsourcing, up top. And then I put the various bid prices. And we have vendors bidding from $2.89 to $3.59. And the 5 different values are in this table here. And of course, I have my quantity that I put in before. So now we want to see how savings changes based on changes in quantity, B11, and then also how it changes based on changes in outsourcing cost per unit. So in a row, I have my inputs to outsourcing cost per unit, and in a column, I have my inputs into the quantity. So let's make a two-way table. So I'm going to highlight my data table, the formula I want to look at, the input column, and the input row. So again, we go over to data, a what-if analysis, data table. This time I'm going to use the row input cell because I have a set of values in a row. So I'm going to click B7. And likewise, I've got something for quantity. That's my column inputs. And so I'll beautify this, make it currency. And there we go. Okay, well, but anyway, you can see the negative patterns and total savings based on the changing quantities and the changing bid prices. So this gives us more information. So again, here was a two-way table. So we think it's instructive to quantify the difference in savings for various quantities and bids. Again, the 5 bids were $2.89 through $3.59. And we used the Excel data table and we constructed a two-way data table with quantity as column and then the bids as row, because that's just how we lined them up. So we have the process. We selected our model for the data table, and then we went to data, what if analysis, and then data table. We put B7, the outsourcing cost per unit, as our row input variable, decision variable, and then quantity as our column input variable. And then the results are what we see here. And of course, we saw it in our spreadsheet as well. So we now have a table that shows savings due to outsourcing for each combination of quantity and bid price. So for example, 75,000 Vipers at a cost of $3.13 would save us $149,250 right there. We can also see the range for the quantity for each bid price that results in negative changes or negative savings. For these quantities and bid combinations, it's better to manufacture than produce. So using the Excel data table allows us to quantify the savings due to outsourcing for the quantities and bid prices specified. However, the table does not tell us the exact quantity where the transition occurs from outsourcing being cheaper to manufacturing being cheaper. For example, it's clear that for a bid price of $3.50, the savings due to outsourcing go from positive to negative at some quantity between 150,000 and 170,000. We only know that the transition occurs somewhere in that range. So we can use another Excel tool to actually give us the exact value. And we'll do that when we return.